The silence can be deafening, and the emptiness overwhelming. At first glance, you may believe you are truly isolated, devoid of companionship. However, contemplate the intricate ecosystems thriving inside our bodies, often taken for granted and ignored. Many microbes and tiny organisms may be living on your skin or within your digestive tract, their existence unbeknownst to you. While these organisms may not possess our level of intelligence, their presence serves as a poignant reminder that solitude can often be an illusion. Similarly, the idea that we are alone in the universe may also be a delusion. Unknown to us, life throughout the universe could demonstrate a vast range of intellect that we unconsciously overlook. Intelligence is an extraordinary feature that has profoundly shaped our own existence, and its manifestation can take diverse and fascinating forms throughout the vast expanse of the universe. On distant planets, creatures may have evolved remarkable and exceptional cognitive abilities, honed by unique environmental pressures and evolutionary pathways. Some civilizations may be less advanced than ours, perhaps comparable to the early stages of human development. They could possess basic communication skills, primitive technologies, and a limited understanding of the universe. While on the other end, many advanced civilizations may have surpassed our own. These beings might possess highly evolved intelligence, capable of extraordinary feats of knowledge, technology, and interstellar travel. Their scientific achievements and cultural advancements could transcend our current comprehension, rendering them godlike from our limited perspective. The diversity of intelligence in the universe surpasses the boundaries of our wildest imagination. The truth is, our self-proclaimed progress might potentially be minuscule when viewed on a galactic scale. In our quest to better understand the vastness of the universe and our place within it, scientists and futurists have devised various scales and metrics. One such measure, the Kardashev scale, proposed by the Russian astrophysicist Nikolai Kardashev in 1964, offers a framework for categorizing civilizations based on their energy consumption and technological advancements. The scale serves as a powerful tool for categorizing and contemplating our future trajectory as a species. The Kardashev scale is a 4-tiered system that measures a civilization's ability to harness and utilize energy. The scale is based on the premise that a civilization's level of technological advancement is directly related to the amount of energy it can command. A Type 1 civilization or a planetary civilization has the ability to harness and use all the energy available on its home planet. This includes utilizing renewable energy sources such as solar, wind, and geothermal power to power their industries and meet their energy needs. They have achieved global unity and are capable of manipulating the resources of their entire planet. A Type 2 civilization or stellar civilization possesses the ability to harness the energy of their host star. They can construct massive structures like Dyson spheres or Dyson swarms to encase their star and capture its energy output. This civilization can tap into the vast resources of their solar system and utilize them to fuel their advanced technologies and interstellar exploration. A Type 3 civilization or a galactic civilization could utilize the energy resources of an entire galaxy, move planets, feed black holes with stars, and even manipulate the fabric of space-time. And a Type 4 civilization would be capable of creating a universe itself. According to this scale, we haven't yet reached Type 1 civilization status, but we're not a Type 0 civilization anymore. Human beings have a score of about 0.73 on the Kardashev scale. One famous theoretical physicist has estimated that if we increase energy consumption by 3% yearly, it would take 100 to 200 years to get us to Type 1 civilization. Once we achieve this status, we'll be able to utilize all the sunlight, wind, and tides available to us. Weather conditions would be controlled by our will, and we'd be able to alter the course of earthquakes and volcanoes and make floating cities. In a strikingly parallel manner, akin to the hierarchical classification of power utilization, different civilizations exhibit distinct methods of communication, which can make it difficult for them to understand each other. Type 1 civilizations, with their planetary scale energy utilization, are likely to rely on traditional communication methods such as radio waves, electromagnetic signals, and optical communication. However, as they ascend the scale, they may harness technologies that allow for more advanced and efficient means of communication. Type 2 civilizations, for instance, may employ advanced and sophisticated forms of long-distance communication, such as gravitational wave communication or quantum entanglement-based systems. Type 3 civilizations, capable of intergalactic travel, may utilize methods beyond our current comprehension, such as wormholes or subspace communication. Bridging these gaps is crucial for establishing meaningful and effective channels of understanding. In order for different civilizations to communicate successfully, they would need to use a common form of communication. In our early endeavors as a Type 0-1 civilization, we began by sending physical messages into outer space. These messages, encapsulated in various forms, served as a means to communicate our presence and curiosity to the vast unknown. As the first major initiatives to communicate with potential extraterrestrial beings, the Pioneer plaques and Voyager golden records were affixed to spacecraft sent beyond our solar system. The plaques, designed by astronomer Carl Sagan and his team, contained symbolic representations of humanity, including a map of our location in the galaxy and a silhouette of a human figure. Similarly, the Voyager golden record, curated by a committee led by Sagan, contained a collection of sounds, images, and music, showcasing the diversity of life and culture on Earth. The Voyager space probes are now 23 billion kilometers or 14 billion miles away from home, making them the farthest man-made object in existence. But while these messages symbolized our curiosity and desire for contact, they also present significant limitations in effectively establishing meaningful communication. The vastness of space poses a huge challenge when it comes to locating and encountering physical messages sent into the cosmos. Plaques and records launched into space are minuscule compared to the immense area they traverse. Space is vast and largely empty, making it highly unlikely for any extraterrestrial civilization to come across our plaques or records by chance. Additionally, physical messages such as the plaques and records are just a form of unidirectional communication. They serve as a representation of our existence and aspirations, but they lack the ability to receive or transmit responses from potential recipients. Even if an advanced civilization were to come across these messages, The absence of a means for them to respond directly hinders the establishment of a meaningful dialogue. The unidirectional nature of physical messages limits the potential for an interactive exchange of ideas, knowledge, and cultural understanding between civilizations. Lastly, the huge differences between celestial objects means that the journey of physical messages can span hundreds or even thousands of years. In the case of the Voyager Golden Records, for instance, it would take eons for any potential reply to reach us. The timescales involved in interstellar communication again make it impractical for immediate or real-time exchanges, impeding the possibilities of timely interaction and mutual learning. After 60 years of sending various signals and scanning the skies, trying to detect artificial signals, we haven't been able to find anything. And we remain unheard. Nowadays, the main world institution devoted to the search for extraterrestrial intelligence is a project called SETI, an abbreviation for the Search for Extraterrestrial Intelligence. This project is based on the use of radio telescopes. Radio telescopes receive radio waves, as we can't go to space aboard spacecrafts. To find that intelligent life, what we look for are radio signals. Scientists use radio telescopes present around the globe to scan the skies for narrowband signals that conspicuously stand out against the backdrop of cosmic noise. It allows scientists to eavesdrop on the whispers of the universe. Just like tuning your FM radio to find the matching frequency of a radio station, scientists often search for signals in the water hole frequency range, which encompasses the hydrogen line and the hydroxyl line. The idea is that these frequencies are natural choices for communication due to their proximity in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxyl, which are abundant in the universe. However, a big hurdle stands in our path. It's the language barrier. Language serves as the bedrock of human communication, allowing us to convey ideas, emotions, and knowledge. But when it comes to extraterrestrial beings, the very notion of language becomes difficult to understand. How do we decipher the codes of an alien civilization? What forms of communication would they employ? These questions lie at the heart of the language barrier of SETI, a challenge that their scientists and researchers grapple with every day. When attempting to decipher ancient languages, linguists heavily rely on contexts and comparisons to other languages to understand their meaning. However, when faced with the challenge of decoding an alien language transmission, these familiar tools are absent. No context is available, and there are no similar languages to draw comparisons from. And assuming aliens use a verbal language is a significant assumption, given that numerous animal species communicate without words. For instance, cuttlefish and chameleons communicate through body color languages, while ants and honeybees employ pheromones to communicate within their species. Even if we understood their language's letters and words, could we really understand what they're saying? Language for us is all based on cultures and requires a common frame of reference. If you were to say, I'm going on a hike and capturing some stunning views with my drone to a squirrel in the park, it would have no way of comprehending your statement. You would need to explain what a hike is, what capturing means, what stunning views are, what a drone is, what technology is, what flying is, what cameras are, what video recording is, and even the concept of visual appreciation, all of which are intuitive to modern humans. If such a scenario were to occur, it's highly likely that the alien civilization is far more advanced than humans, having achieved interstellar travel and possibly even faster than light travel. Therefore, it becomes crucial for us to demonstrate that we possess at least a basic understanding of the universe in order to establish meaningful communication with them. Mathematics, as far as our knowledge extends, is a universal language, a language that transcends cultural and linguistic barriers. By harnessing the power of mathematical concepts, we may unlock a means of communication with alien civilizations. Foundational concepts such as addition, subtraction, multiplication, and division are universally applicable, serving as a framework for numerical communication. Regardless of location in the universe, the fundamental truth remains that 2 plus 2 equals 4, and the ratio of a circle's circumference to its diameter is approximately 3.141592, and so on. While the specific numerical labels may differ across civilizations, the underlying concepts remain unchanged. One approach to mathematical communication with aliens is through the use of bits. In digital communication, a bit is the smallest unit of information, represented by a binary value of 0 or 1. By using a series of bits, we can encode and transmit messages. For instance, we can allocate a unique series of bits to each letter of the alphabet, creating a binary code that represents written communication. Thus, we can introduce the concept that 1 bit signifies the letter A, 2 bits represent the letter B, and so forth. This binary code could serve as a foundation for communication, allowing us to transmit longer written messages that could be understood by an intelligent alien civilization. Therefore, we could show the aliens our understanding of math, though it would be a tremendous intellectual challenge humankind has ever faced. Composing a message that can be understood by aliens will be extremely difficult, and conversation may almost be impossible. Extraterrestrials could be millions of years more advanced than we are. These hypothetical life forms may have long abandoned their biological bodies to exist solely within a computerized body. In this scenario, they may have relinquished their individual consciousness to merge into a global digital network of minds, giving rise to a vast collective consciousness. Due to this huge intelligence gap and the absolute cluelessness about the possible aims of an extraterrestrial intelligence, is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials. However, even if there were potential risks involved, even if another civilization can come to Earth, it's already too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There's no added danger of transmitting signals through active SETI. Considering the information we now possess, it is plausible that a first contact could occur in the near future. It's also possible that some civilization has already listened to our messages, but haven't responded because they like it that way. All these processes talked about are known as active SETI or METI, messaging extraterrestrial intelligence, which involves the intentional transmission of messages or signals from Earth into space. By taking a proactive role in initiating communication, scientists hope to attract the attention of intelligent beings that may be listening or capable of receiving the transmitted signals. This shift from passive observation to active engagement reflects a growing belief that humanity should actively participate in the quest to establish contact with other civilizations. Nevertheless, how is it possible that, given the huge possibility of other civilizations, we haven't yet received any evidence of their existence? The question of great silence was first raised by legendary physicist Enrico Fermi, and is famously known as the Fermi paradox. Speaking to his colleagues once during lunchtime, he raised a seemingly simple question. So, where is everybody? Why haven't we seen any proof of alien civilizations yet, given how likely it is that they exist? Perhaps, at the end of the day, maybe they simply don't bother to communicate with us. When you consider our civilization's level of development, the answer is pretty obvious. Why would they? The logistics required for interstellar travel are only available to civilizations that have reached Type 2 at the least. And in their eyes, we're not worth it. What person in their right mind would try to communicate with ants? How would an ant be able to recognize that someone's trying to communicate with it? After all, in terms of our development and technological advancement compared to them, we are akin to highly developed ants that have taken over an entire planet. This is called the zoo hypothesis. The extraterrestrials may have chosen not to initiate contact or reveal their presence for various reasons, such as respecting our development and not interfering with our evolution, avoiding potential conflicts or cultural clashes, or simply having no interest in communicating with less advanced civilizations. Another explanation for the Fermi paradox is that we may have already received those signals, but we haven't realized it. We haven't perceived the signals, or we haven't been able to understand or decode them. In this case, some strange signals from outer space have been received. Their origins are now being investigated, and they have posed serious questions for scientists. The most famous signal that has been detected came in 1977 at Ohio State University's Big Ear radio telescope. While listening for signals from another civilization, a strong message spread out over frequency was observed. It looked exactly like the kind of signal we would want to receive from extraterrestrial beings. During his work on the night shift on July 15, 1977, Jerry R. Amon, a professor at Ohio State University and a volunteer for the SETI project, observed the peculiar transcription of the radio signal made by a computer on a section of paper feed. Later, it was confirmed that this signal was the most intense anomalous signal detected up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals. It had come from the constellation of Sagittarius. The computer processed the received signals into a series of alphanumeric characters, producing the sequence 6EQUJ5. In fact, it was so astounding that when the technician looked at the printout the next morning, he wrote "wow" in the margin. And that has become known as the wow signal, which has kept the international scientific community on edge until today. Amon and his team conducted an exhaustive examination of the signal and eventually ruled out any interference coming from Earth. Over the following month, the operators of the radio telescope attempted to relocate the signal, but they were unsuccessful. Astronomers have looked at the same part of the sky many times since then, hoping to find the wow signal again, but they have never been able to replicate it. The key to progress in SETI is to find a signal that is as remarkable as the wow signal, but not just once. It needs to be found repeatedly. Today, the origin of that signal is still under investigation. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe. That's why human beings and their enthusiasm for knowledge and exploration have started the search for intelligent life with the hope of sooner or later finding it or being found by it. The first contact may not happen within our lifetimes, but whenever that occurs, it will be a turning point in the life of the human species. What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Will mankind be prepared? On November 13, 2004, scientists at NASA were using the Hubble Space Telescope to capture images of a previously unexplored and empty region of the sky. With low and minimal expectations, they did not expect a lot in return. Just a dark and empty image, and the scientists could call it a day. The telescope would return, however, an image of a planet located just 25 light years away from us, orbiting a star double the size of our sun. This was the first time a planet was directly observed through a telescope. Against their expectations, the scientists could not wrap their heads around what had just transpired. Never before in history had a planet been found out on the basis of direct observation. In fact, the person who discovered it said he nearly had a heart attack. The image that was captured reveals a star at the center, now formerly known as Fomalhaut, which is surrounded by huge swirling clouds of dust and debris, encircled by a continuous round asteroid belt. And among these millions of rocks dotting the image lies a planet surrounded by real mystery. Once named Dagon, this planet, clearly visible in the photo, never truly existed. What you're seeing right now is nothing but the phantom of a planet that never came into being. Astronomy has not yet encountered anything like this before. What could it be? A glitch in the matrix? Could someone else be involved? Where could a whole planet disappear to? In 2004, when NASA first discovered Dagon, something seemed off right from the start. It was behaving strangely, defying the odds. Because according to what we knew, planets like Dagon that are 2 to 3 times the size of Jupiter shouldn't have been able to form around such a young star like Fomalhaut, which is just 400 million years old. Our sun, for comparison, is about 4.6 billion years old. Additionally, since its star is surrounded by a protoplanetary disk of gas, ice, and dust, the first planets to appear around it should be superheated and glow in the infrared, instead of this Dagon that emits ultraviolet light. Moreover, that planet was incredibly radiant, shining with an intensity rarely observed on exoplanets. Its remarkable brightness raised numerous questions among scientists, but for the most part, scientists just thought maybe it's the presence of an expansive ring system akin to Saturn, which could enhance its reflective properties, thus intensifying its luminosity by capturing and redirecting more sunlight. And what's more, research showed that Dagon behaved in a very strange manner. Though it's unknown how much time it takes to make one trip around Fomalhaut, according to the estimates, the speed of the planet just kept on increasing while it cruised on its 1,700-year orbit around its star. During those early years, It seemed obvious that Dagon was acting in a way that a legitimate